as we said, the most important data types are numerical, datetime, and string or text. Now, text has its own special way of comparison and operation, so it's worth discussion here, because if you think about numbers and the datetime, it's a series. There's a clear idea of what is greater than or the large, what is larger, what is smaller, what is front, what is at back. So it's a series. It's just one single series. The idea is simple, but for string there are much more special operations. Let's talk about some of the operations here in this session. So first of all, how do we do string comparison? Text comparison is actually character by character because each text string is a series of characters, right? So when we compare two strings, we compare first char first. If the first char equal, then we compare next. Then we compare next until finally we can determine which one is larger. So here we have a comparison between introduction and the introductory. We will compare the first two letters, two chars, uppercase I equals to uppercase I. So we go to the next one, lowercase n equals to lowercase n. And then the next one, lowercase t equals to lowercase t, all the way until we get to the comparison between lowercase I and the lowercase o. That's when we can determine which one is smaller. And the result of this comparison is the result of the string comparison. A char comparison is based on ASCII2. ASCII2 is a standard encoding system for most of the computer systems, right? So here is the ASCII2 chart where you can see up front 00 is now. NUL here, this now is basically similar to the NULL now we have in, it means nothing. It means nothing, not existing. So if you have two characters, two strings, one is the A, another is one is AA, another is A, then AA is greater than A. Why? Because the first two characters is the same, right? Both are A, but the second character, AA's second character is A. A character is now. There's nothing. There's no second character. It's a now. So AA is larger than the A is larger than now, which means the string AA is larger than the string A. So the short one always wins. If the first few characters are the same. Now, other than this, now the most important three sets is numerical value 0 less than 1 less than 2 all the way until 9. Then numerical value is smaller than all the alphabetical values. Within alphabetical value, uppercase value is smaller than lowercase values. And within each set of alphabetic, A less than B less than C all the way until Z. So numerical value, uppercase value, lowercase value. This is how you determine the calculation. Now, there's a lot of common ground between string comparison and the other normal comparison. You can use logical operator and or not. You can use between and. Now, one catch for between and is one thing to pay attention is the end value is the upper limit of where your string can go. For example, if you are comparing A and F, between A and F, then A or B or E something or F itself are all included in this comparison, are all valid, will always give you a true for this comparison, but it will not include F1. Some students thought that if it's between A and F, then everything starting with F will be included, will also get true. That's not true. That's not correct. If the end at F, then it stops there. Anything after F, like F1, F2, FAAA, all these will be return false in this between end. It will be outside this between end range. Now, some DBMS can do implicit type conversion. So it can interpret the following as a numeric comparison, such as the actual tuition greater than 650, but this 650 is actually a value. It's actually a text. It's a string. But the Postgres, some database DBMS, including Postgres, are smart enough that it will guess that when you put this string in a numerical comparison with a numerical column, you must mean that you are considering this string as a character, as a number. So it will do the conversion. It will automatically convert this 650 into a number 650. So you can do that. Postgres will do that. Will do the comparison for you, and it looks good, right? But what I'm telling you is, don't do that. Don't trust it, because if DBMS if DBMS can interpret it this way properly, sometimes it can also give you trouble, and at that time you won't even know something is happening, because DBMS is trying to do whatever it thinks is the right thing and best thing. It doesn't consider this as an error, so you are not going to get any error message. So my advice is don't do this. Don't do this implicit conversion. Don't ask a DBMS to perform outside any conventional wisdom. DBMS can take a guess, but your job is to stop it from guessing. You should properly tell DBMS what you are supposed to do. And I'm giving you an example here. What do you consider is greater? Which one is greater, 0, 90, and 10? If you think these two are numerical values, then 90 is greater than 10, right? If you think these two are text string, then you do a string-to-string comparison, then 1 is greater than 0. That means that the string 090 is less than the string 10. So even this seemingly simple comparison can give you trouble. Don't expect DBMS to interpret this properly. And this happens a lot in text reading, because a lot of financial application, when they generate data, in order to make the data fit it into certain framework, they always add leading zeros. So this comparison, if you try to interpret it as a char, that will give you big trouble in comparison. Oops, what did I press? Okay, so I think I got this part down. Lesson learned: don't trust DBMS. Don't trust their conversion. Always, if you need to convert yourself. If you need to do type conversion, do it yourself. Okay. A more interesting part for string pattern matching, and it's pretty much limited to string itself. Not on any other data types. Is a pattern matching. We in real life, in real world, frequently ask for pattern matchings. How many times do you hear someone asking, "Oh, I'm looking for someone's name is Luke. I don't remember his last name, but I think it's I think the last name. I think the first name is Luke." What does this mean in a pattern matching world? This means you are looking for someone, a student's name starting with Luke, plus an unknown number of characters following this LUKE, right? It should be Luke space with whatever last name that you cannot remember. It will be LUKE plus an unknown number of characters. So another thing is, any I'm looking for any SQL course in the course category. If you say any SQL course or any course with a name who has a SQL in the name, you are looking for a course name starting with an unknown number of characters. Maybe 0. Maybe it starts with 0. Maybe the course name is just SQL introduction, right? Then followed by the word SQL. That's the word. That 3 character is the required SQL, followed by an unknown number of characters, and this can be 0 too. Maybe the course name is just SQL. Maybe the name is SQL introduction, SQL introduction or SQL fundamentals. Then or it's an introduction to SQL. So these are all potential pattern matching matching patterns that can fit your requirement. So you are looking for a name, a text string with SQL. Then you are looking at a string starting with an unknown number of characters. Can be 0, can be none, followed by the word SQL, followed by an unknown number of characters. So these two are two very common usage, I would say most common pattern matching requirements. Now, how would we do that? We do that with the like clause of where, like operator in a where clause. It's a string pattern with a wildcard matching. When we say like starting with Luke, we already some text string starting with Luke, we already say you can interpret that as Luke plus the unknown number of characters. This unknown number of character is a wildcard, right? We use a % sign for multiple character wildcard and underscore sign for single character wildcard. % sign stands for an unknown number of unknown characters, of any characters. Underscore stands for one single character of any characters. For example, if we want to say starting with S, that will be S %. If we want to say starting with SQL, then it will be SQL %. Here % stands for unknown number of characters. If we want to say ending with T, then it's a %T, an unknown number of unknown characters, then followed by T. T is a requirement. Nothing, anything before T that fits into the %. So you can even have T itself. This also meets the requirement of ending with T, right? And then we can say starting with S and end with T, S %T, it can be sit. It can be maybe SEAT, seat. Maybe it can be sweat, SWEAT, right? Maybe it's just the % stands for 0 characters, ST. All this fits into this pattern. Now, then we have the contain the pattern SQL, contain the 3 characters SQL. That will be % SQL %. They will give us anything starting with 0 to many characters, followed by SQL, followed by 0 to many characters. So like we said, SQL itself, SQL, 3 words, fits into this pattern. You can have SQL fundamentals also fit into this pattern because the first % will match nothing. The next % matches the fundamentals. Then you can have an introduction to SQL. Introduction to fits the first % and the second % matches the empty string. Then we can have containing the word SQL, regardless of case. In this case, we will just do an upper conversion, convert everything to uppercase, then perform a like, right? That will give you more flexibility. That's when we say you can use a function to achieve a lot more than simply pulling data. This is what you can see. One of the example, by applying an upper function in your work class, you have a more flexibility in identify all the SQL courses. In addition to uppercase SQL, now you can detect the lowercase SQL or uppercase S with lowercase QL, right? So these are the patterns that we frequently see: starting, ending, containing, or converting with auto case to a case insensitive comparison. Similarly, we have underscore, like. Underscore stands only for one character. If you want to check something starting with one of any character but continues with TAT, then that's what you see. Underscore TAT, or anything like SQ underscore. SQ underscore can give you SQL, can give you SQA, can give you SQR, SQK, SQZ, anything. The last four character unknown, but starting with state, there will be state underscore 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 underscore. And you see that we have this 4 underscore here, and this fits into exactly four characters. Excuse me. Well, let's check the difference between underscore and the percent. Underscore means there must be a character that cannot be empty. If I have 4 underscore there, like what we just see, a state, then I have to have 4 character matching this. I can have state underscore state space equal. I can have statement. I can have state space XYZ, but I cannot have states. I cannot have STATE NY, state NY, state New Jersey. That doesn't work because it requires 4 characters here. On the other hand, percent means there might be nothing or 1 or many characters. So if you put state percent, each percent can mean 0, can mean as many as you want. So state of New Jersey, state of New York, states, statement, all fits into this pattern. And note that usually I put a 4% sign here. Usually nobody does that because 1%, because percent itself can mean nothing, can mean 0. So putting multiple percent together doesn't mean anything, doesn't help. All the other percent can become empty. Only 1% stands. In real life, people only write percent once. I write this here just for demonstration purpose. And also, one thing to note is underscore. Since we talked about the difference between underscore and percent, I should also mention that underscore is much less used. Much less used. The reason is the fact that you are doing wildcard matching means you are not sure about what's in the string, right? You are doing a SQL search. You use a percentage, means you don't know what other characters, what other strings may be in that string. So if you don't know what other characters are, how do you make sure? How can you be so sure that you know there are only 1 or 2 characters? It doesn't make sense, right? So in most cases, people will use percent. People won't use underscore. However, you still need to know what percent is, underscore is, and you still need to know that underscore stands 1 and only 1 character. Now there's also something I need to mention here, because we are going to use the Postgres SQL, and most of you, I assume, will install your Postgres SQL on Windows. And when you install, you will be using the default locale. There's an issue with Postgres SQL installed on Windows with default locale, which is the comparison, the greater than or equal to, less than or equal to, and the between and comparison. For varchar and varchar is case insensitive. So if you see there's the comparison uppercase L comparing with lowercase h, we already mentioned that h lowercase is a higher in order. So uppercase L should be less than h. But if you run this in Postgres installed on Windows with default locale, it will return true. All other comparisons, however, are case sensitive. And all comparisons on Postgres installed on Linux is case sensitive. And if you install Postgres with many other locale, it will also be case sensitive. So the issue So this behavior is actually an issue, a bug in PostgreSQL. They shouldn't do that. It's a bug on their side. But because this one is a Postgres installed on Windows with default locale, is what a lot of our students will be doing. So I have to mention that, and you have to be aware of that. This is a PostgreSQL behavior on a specific situation. It's not SQL standard. It can be changed, but usually this is done by administrator, not by our data scientists. So for you can change that locally using clocale or ccollation, but this is too advanced for our course. So I will show you what I can do, but I don't expect you to do that yourself. Instead, if you run into this in your work, you need to let your administrator know. Okay, so let's go to Postgres pgadmin, and we will run some real SQL. So first thing, I'm still using the same database I use, same SQL tables I created just now. So I'm going to select from registration where student name equal greater than H, which will give me look and layer. Right, we have five rows, and 3 are looks, 2 are layer, and L is greater than H, right? Now, what if I want to show student name greater than L? It's the same thing. Now we come to the point where I'm comparing this these strings starting with L with upper L with H. Technically, I shouldn't receive anything, but still I'm receiving all 5 rows because of a Postgres issue. However, if you run this, because mine is installed on Windows with local default locale, so I have this issue. But if you install yours on Linux, then you shouldn't have this issue. But I can change the behavior by adding this collate C. I don't expect you guys to do that. However, I'm just telling you, you can do it. You can force Postgres to behave the standard SQL way. You can see that once I add this collate C, which tells what the character set is supposed to be using, I'm getting the correct result where uppercase H is not greater than uppercase L is not greater than lowercase h, right? So if you run, I'm not going to test you on this because this is a SQL Postgres issue. That's a bug on their side. I don't expect you to work on that. But you better keep this in mind. And if you run into this, you can let your administrator know. Usually, administrators should know how to fix that. Now let's see where actual attenuation greater than 300, right? That's what we just mentioned. 300 is a character, it's a text string. Actual attenuation is a number. But somehow Postgres understands that I'm comparing a 300 character. I'm comparing a text string with a numeric value with a greater than sign. That means I probably want to consider this string as a number. That's what it does. It applies this 300 the value properly. However, this is not what I'm supposed to see, right? What if I'm going to do this 10 greater than 0, 90, or 10 greater than 90, 090. If we are doing a string comparison, then we are comparing 1 to 0, which means this is the true. If this is true, then I'm supposed to select all the rows in registration, which is the case, right? So here it's not comparing as if they are text string, they are numbers. However, when you do this, most likely, because Postgres may be converting, so it may be converting this to string, it may be converting this to number. You don't know, and you won't see any error message. So this is a lesson. I hope you guys can learn that you should not let Postgres do the guessing work. Instead, do explicit conversion in your code. And then we have this between and remember, look and lar are both greater than L. So this between L and A and L will not return anything because look and lar are both outside of L. But if I put a M, then I'm going to see all 5. Then now come to the percent side. If I want to see introduction, anything starting with intro, that's introduction to the force. Anything end with 101, that's the serious favorite class. And how about anything with force inside? This time it returns one row with introduction to the force. But if I have something like a force this, force that, then I will getting that course too. And now we have to do the conversion of force, conversion of a case. Conversion of case, I can do both this way, and I can also do an opposite this way. And this usually happens when you have a long string and you don't want to change that, which works. If you want to manually change everything to uppercase, that's fine too. Like the first one, you just how much effort does it take to change force to all uppercase? But if you are copying something from somewhere, you probably don't want to change that. You just want to add an upper function around it, which will bring you the second way of writing, right? So both are fine. And now, underscore. I'm going to insert 2 more courses, one from Master Soda, one from Master Yosoda. And now I'm trying to look for course name, instructor name with underscore ODA. And I'm going data from Master Yoda and Master Soda, right? But I'm not going to get anything with from Yosoda because YOS are 3 characters. Okay, now let's have the most fun part, which is the course Dagobah Surviving Camp. And Dagobah is a planet in Star Wars galaxy. It has 7 characters, right? So now I want to, the first where clause, I'm going to check 7 characters, 7 underscore. And the second one, I'm going to check 6 underscore. So because Dagobah itself have 7 characters, I do expect the first one to return this to me, but I do not expect the second one return anything because Dagobah is 7 characters, right? So 6 characters, 6 underscore does not match the word Dagobah. However, how about I do 7%? It works, right? How about 6? It works too, because when you have multiple percent, it's actually the same as 1 because all the other percent are just, you can consider them just as an empty. Then with a percent, we'll cover anything anywhere from 0 to 7 or to even more values. In fact, you can also change this to 1% and it will work too. Right? So this ends our string operation, but basically there are a lot of ways of organizing your query around string, and this will be, I can confidently tell you, this will be one of the most important tasks in your daily job, no matter what job you are working on.